Good evening. We're back. If you're in the chat, please put your name. Put your name if you're in the chat. Please put your name if you're in the chat. If you're in the chat, please put your name. Hi, Antonisha. Welcome. Where are the others? Right. There you go. Okay. Okay, I see Anisu. I see you. If you're in the chat, please put your name. Right. We want to get started with physics real quick, and then we'll see. So I'm going to solve some questions. We're trying to finish this calculation part. Okay, we want to finish this calculations part of physics as early as we can, as quickly as we can, and let's see how it goes. Okay. Put your name if you're in the chat. Okay, I see Eric. Well done. Welcome. Right. So we were doing chem, and we know that we have 12 chapters to do. So we started with the 12th, with the 11th one. We're going to do all the 12 chapters. Now here in physics, we know that for the next, I don't know, 6 months or whatever, for our IGCSE physics, we have 6 units to cover, okay? To cover thoroughly and talk about everything and do a lot of practice questions. So it's going to be more of practice, okay? You do more work than I do. I only do 25% of the work. 75% of the work is you. So let's see how it goes. I'm just going to give you the pieces, and then work belongs to you, my friends. You are the ones. You have to practice, okay? Work hard for that A star. So here we want to say, we remember, if I put the things, units, let me put, okay, the units that have a lot of formulas, we want to do calculations, right? So today we're focusing more on calculations again, and we want to just do any question that says calculate. So we want to do calculation questions. Real quick, if I can do a few of them. Right, we know that we have 6 units, and if we put those 6 units, it goes like this. You have unit 1. The units that have a lot of formulas that you have to know would be unit 1 and unit 4. Okay, so unit 1 and unit 4, we are going to focus on them a little bit later. Unit 1 and unit 4. Unit 1 is going to be motion. It's called motion, forces, and energy. Motion, forces, and energy. It used to be called general physics, unit 1. And it's the one where you have motion, you talk about the motion graphs, then you have momentum, then you have Hooke's law, then you have Hooke's law, then you have moments of a force, then you have to calculate work, energy, and power. So there's work, there's energy, the 2 types of energies, you should be able to calculate them. You should be able to calculate power, you should be able to calculate efficiency, you should be able to calculate pressure, you should be able to calculate, what else have I left? Yeah, in momentum, you should calculate momentum, and you should be able to calculate impulse. Then you should be able to calculate acceleration, the force, and all that stuff. You should be able to calculate the resultant force and all these things. So these are a lot of formulas for unit 1. And unit 4, this is electricity and magnetism. So electricity, you have to know how to calculate current. the formula for current. Then you need to know Ohm's law. Then you need to know how to get power. Then you need to know how to get electrical energy, stuff like that. Then you're going to need to know about circuits, okay? Series circuits. You need to know about series circuits. Then you need to know about parallel circuits. Then you need to know about, these are calculations, okay? Things that that you'll be having to know. Then you gotta know transformer calculations. Transformer calculations. So all these are on calculations and we have to talk about them, okay? It's not a problem for us. We want to just make sure we are able to calculate all 6 units. So let's start with the other 4 simple units, which is going to be unit 2, okay? Then you have unit 3, then you have unit 6, okay? Unit 6, we'll talk about unit 5 a little bit down there. So let's see. Okay, I see Lilentle. Hi, I see Lechakwa. Well done. So let's just quickly do some progress. So unit 2, we know that it is thermal physics, and we know that there is only one calculation which may come, and we're going to get those marks. Delta E is equal to MC delta T. We are putting the formulas that we're going to need, and we are going to be going through the questions. So delta E is equal to MC delta T. So I'm going to do an exercise with you. And in our exercise, we'll be going through past paper questions, and we should identify the unit. Oh, this is unit 1. You can see it's asking about things like moments and things like that. Give me a second. I hope you can hear me better now. You should be able to say, oh, this is unit 1. Hi, Antonisha, I see you. Well done. Right. So you should be able to say, oh, this is unit 1. Oh, this is what, just by looking at the questions. So they'll give you unit 1, you scroll down a little bit, unit 2, you scroll down a little bit, unit 3, you scroll down a little bit, unit 4, you scroll down a little bit, unit 5, you scroll down a little bit, unit 6, and you can get calculations, a lot of calculations. This is going to be for unit 2. Unit 2 is thermal physics. You see them talk about heat and all these other things. And they'll ask you to calculate energy transferred, or they'll ask you to calculate specific heat capacity or whatever. Here are the things, okay? The things that they'll ask you. They'll ask you one of the things in this formula. So this is going to be the energy transferred. This is going to be the energy transferred. This is going to be the mass. This is going to be C, which is the specific heat capacity. Then delta T is going to be change in temperature. Change in temperature. So this is going to be what we have. MC delta T. Then for unit 3 is about waves. So when we are in unit 3, we're going to be talking about waves. They'll say something about waves. What we have to know for this unit is the first formula, where if they ask you for wavelength or whatever, V is of frequency, V is F lambda. Okay, V is F. You know the naughtiness of these guys? They will not give you speed, but they'll mention something which should help you know the speed. So many of the times they won't explicitly say this what the speed is, but then they'll give you something which you're going to use to know the speed. So this is going to be the speed of the wave is equal to the frequency by wavelength. So we can find everything. Lambda is wavelength. That's the formula number 1 that we're going to use. There is no way. Okay, yeah, definitions, we'll start them. Don't worry, definitions are so small. Let's just make sure we are thoroughly done with this. Let's just make sure we're thoroughly done. There is no way you get a calculation which is not on this that I'm giving you, okay? Then we know we have n. N is equal to 1 over. The next lesson, I'm sure. N is 1 over sine C. Just prove to me that you're good at all calculations, okay? Then N is equal to sine I over sine R. Sine I over sine R. This is the second formula for N. Then the last formula for N, which is refractive index. I'm going to give you the name. It is going to be equal to speed of light in a vacuum. This is a cheat code, guys. Trust me. Okay? Imagine somebody thinks there's so much and everything. You know that you only have 4 formulas for unit 3. There's no way you're going to get a calculation question which won't be here. Speed of light in a vacuum over speed of light in the material. Then you get refractive index. Refractive index means how much is the wave going to bend. Waves bend when they pass from one medium to another, from air to water or whatever. If a wave was coming like this, when it gets here, it can bend like this instead of continuing the way it was. So this bending, we want to find out how much will it bend, the refractive index. And here are the ways of getting it. Number one is 1 over sine c, and c is the critical angle. C is the critical angle. N is the refractive index. N is refractive index. Then that's the same with here. This is called Snell's law. If they say use Snell's law, you just use this one. It's nothing. I, this is the incident angle. They will give you I. Okay, N is refractive index, like I always say. Then I, this is the incident angle they'll give you. Okay, they'll give you incident angle. Then this is the angle of refraction. That's fine. We have all the formulas we need. Unit 3, we are ready for you, man. Hi. Then unit 6, we put the formulas. So let's do it. So anything from unit 2, unit 3, unit 6, unit 5, we should do it non-stop. I'm going to give you questions, and I want you to prove to me that you are now able to do all these units. You are fine with them. You got to prove to me. You have to solve those questions. The formulas are here. You just choose the formula which works for that thing. We know that we have age of the universe. Age of the universe for unit 6. It is equal to 1 over h0. And h0, this is called the Hubble constant. So this is the first formula, okay? Age of the universe. Then after you find age of the universe, ish. Things are clashing ugly here. It's becoming very ugly. Let me remove this. So let's make this unit 3. This is you all unit 3 now. Then so we have unit 2, we have unit 3. Then below here we'll put our unit 6. We said age of the universe is equal to 1 over h0. Then you can find it. h0, this is the Hubble constant. You'll be given in each question, okay? Whatever question. Then you should be able to know that there's V is equal to h0 times d. Okay, V is equal to h0 times d. This is going to be the speed. It's equal to h0 again. This is the Hubble constant. We know what it is. Then d is the distance. You should know this formula, okay? Formula number 1, formula number 2. Then, in case we need to find any of those things, then formula number 3, okay, we should know that 1 light year, let's put the third, we should know that 1 light year is equal to 9.5 times 10 to the 15 meters. Then 1 light year is equal to 9.5 times 10 to the 12 kilometers. So if you have a light year, you want to convert to kilometers, you multiply by 9.5 times 10 to the 12. If you have a light year and you want to convert to, you have to remember this. No one is giving you this. You have to remember it off your head. Okay, nobody's going to give you this. So you must know what 1 light year will give you. You must know this number 2. You must know number 3. Then you must know that speed is equal to distance over time. It will work, okay? Speed is equal to distance over time. When you're talking about speed of planets and all that, just need to know distance over time. And we have another one for orbital speed. It will be distance over time. The distance will be, speed is v. It will be equal to 2 pi r over t, okay? It is still like distance over time. This is going to be radius. So if you have the radius and this is the period, which is the time to go right round, then you can be able to find speed. So with this, you should be fine, okay? With this gear, this should protect you. You should be fine. Remember, you should know the speed of light and the speed of sound. Speed of light, c, is equal to 3.0 times 10 to the power of 8 meters per second. Then the speed of sound. Speed of any light. Okay? X-ray, gamma ray, all those, these are types of light. So they all move at this speed. Then speed of sound is equal to 330 meters per second. Speed of sound in air. There we have it. Okay? We have everything we need. Nothing should ever confuse us. We are fine for unit 6, which is space physics. Okay? Unit 6 is space physics. When it comes to calculations, we have everything we need. We should get 100%. Prove to me you're going to get 100% there. Prove to me. I'm going to give you questions and then you have to prove to me. Okay? You have to prove to me by solving all those questions. Then now, unit 5, we said what you must just know for nuclear physics. In terms of calculations, the only thing you'll be asked to calculate is half-life. And what you must know is that when you go from an amount, okay, it will go to, when it reduces by half, then it will, let's start with 1. Then it will go to half, that's 1 half-life. From half, it will go to 1/4, that's 1 half-life. From 1/4, it will go to 1/8, that's 1 half-life. So you'll be counting the number of half-lives. So this is going to be T half, then this is going to be another half-life, T half. Then this is going to be another half-life, T half. Then what you're going to say, you would just say number of years that something has taken will be equal to the number of half-lives, okay? So you can say 1 half-life, how many it is in years, times the number of half-lives. You can say length of 1 half-life, okay? Length of 1 half-life times the number of half-lives. This will give you the number of years that something is taken. That's what we are going to do. So first we're going to be finding how many half-lives. We'll be dividing by half, going down, going down, going down, seeing how many half-lives. Then we'll multiply the time it takes for 1 half-life by the number of half-lives that have happened there. And that's how we're going to get our answers. Anyone with a question? I should zoom out a bit. So the only units that you're not able to do is unit 1 and unit 6, right? Is it not? The only units you're not able to do is unit 1 and unit 6, right? That's the unit 1 and unit 4. Those are the only ones. Now, the others, I want to see my answers. I want to see my answers. Right, let's go to questions. Those are the only ones, unit 1 and unit 4. The others, I want to see my answers in the whole paper. I'll just do 1, then we'll call it quits, okay? Then you try and we will revise. I'll give you a paper that I want. We can all even go to this here. I think I like this paper. Right, let's start from the back. We're not doing questions from unit 1. We know that. Okay, yeah, the sun eventually, blah, blah, blah. This is unit 6, which talks about the sun. It's the only one, it's space physics. Let's look for calculate. Here, calculate distance. In kilometers. Distance in kilometers. Did they give us in light years? Yeah, they did. 7,000. So you're going to say distance in kilometers is equal to 7,800 light years times 9.5. Okay, you say by multiplying, you put a dot, which is like this. By 9.5 times 10 to the power of 12 kilometers. We are going to get an answer. So what am I going to get here? I just multiply. Whatever answer I get, that's the final solution. Let me take the simple little calculator I have here. And let's multiply. Scientific. 7,800 times. You say, 7,800. You can say open bracket 9.5. EXP 12 times 10 to the power of 12 is EXP 12. I get 7.41 times 10 to the power of 16. It gave me the answer. So it's 7.41 times 10 to the power of 16. I still saw some people who put this type of comma. What is that? You put a full stop as your comma between numbers. We are not in English. This is not grammar. Please, you don't put this type of a comma with numbers. It's illegal unless you're writing a sequence. So anyway, thank you for that. I can see this is about waves. This is topic number 3, but actually there's no calculation at all. Okay, that's fine. I can see this is unit 5. It is about it's nuclear physics, but there's no calculation, okay? You're just writing things here. Fine, we move on. Oh, here's a calculation. Clockwise moment. This is a calculation from unit 1. This is a calculation from unit 4, electricity. Electricity, we don't want to do you, man. Come on now. What is all this? Oh, waves. Unit 3. There we go. Unit 3 is back, guys. And it's a calculation. We can see some rays and stuff. We don't care about any theory. Show your working refractive index. We know the formulas for refractive index. We have 3. N is equal to 1 over sine C. Then we have another one. N is equal to sine I over sine R. That's Snell's law, which if you look here, you have I, you have R. So let's go ahead and let's use it. The last one for speed of sound in a vacuum over speed of sound. We don't even need to talk about it. So let's talk about this one. This is the one that works. You just look for the one that works in that particular situation. When they say show that, okay, show that is like they are saying to you calculate. So if they say show that the refractive index, ignore their answer. Just calculate the refractive index. When? And you must get this answer. So let's calculate. N is equal to sine I over sine R. Okay, so we can say N will be equal to sine. What is our I? Our I is 45, so it will be sine 45 degrees over sine R. They are checking if you know. We know these things. Calculation, we are not losing a single mark in the whole exam. That is not happening here. That's not happening. Hell no. Sine R is 30 degrees, so it will be sine 30 degrees. You should refuse these things. N will be equal to, punch in degrees. Make sure your calculator is in degree mode. You must get 1.4 something, and they just want you to say 1.4. Now calculate the critical angle. Well, the only thing that you know that has the word critical angle in calculations is this one. So what are you thinking about? Use the formula. We know all the formulas. We are fine. So we put the formula. N is equal to 1 over sine C. 1 over sine C. Then what are we going to do? I'm teaching you. You should learn this trick until you are now all good at it, okay? Of applying the formulas. You trust your formulas. You're just using them. Okay, we are almost done now. So what you do is when they ask you to find critical angle, obviously it means we have N. Yeah, we have it. Isn't we just found it in the previous question? So now what we're going to do is we need to make C the subject. So here's what you do in the next step. You should know that if F is 1 over T, which is true, F is 1 over T, it also means that T is 1 over F. T is 1 over F. So you can flip them. You flip them both. So here, if N is 1 over this, that means 1 over N. If I flip N, it will be now sine C, okay? You can flip. So it's like you can say here, 1 over F is T. F is 1 over T, so 1 over F will now be T as well. That's true. That's very true. So that's how you find each other. So here we'll say 1 over N is now sine C, okay? That's what you do. Then you take sine to the other side because we want C, the critical angle C. So you now take sine, it comes here, it now becomes sine inverse of what? Of 1 over N. When sine goes to the other side, it becomes sine inverse. It will be equal to now C. So now you're going to just say sine inverse of 1 over 1 comma, it was actually 4, 1, blah, 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 blah. So you divide, you get your C. Okay, what do you get? You say second function sign, then 1 over 1.41. What do you get? Or close bracket. What do you get as your answer? You should get an answer of C. That's what we're going to be doing. This is unit 3. How do you know? It's waves. Anything to do with rays of light, rays of what? So your biggest job from now on is going to be to identify which topic something is from. Okay? A lot of the things, moments, force, what, they are from unit 1. So don't worry about them. Unit 2, they have to say something about energy. Unit 3, it has to be a wave. Something to do with those things that we saw. So here, what is the answer here? Somebody can get me the answer. Let me punch it. 46 degrees, or somebody said 46 degrees is equal to C, okay? So that's the answer. You understand? 1 over 1.41, blah, blah, blah. You get, yes. It's actually 45.1. So it's actually 45. So it'll be 45 degrees. That's the C. So you'd say C is 45.2 or whatever. If you want to say 45.2 degrees, it's fine. Okay? Let me say second function sine 1 over 1.4. Oh, 1 over 1.4. No, make it the longer one. 1.41 something something before you round it off. So it should be 45.2 or something. It keeps going down, something like that, degrees. And that's your C. That's your critical angle. I'm proud of you guys. You're doing amazing. So that's just what you must do. Don't even think, here. If you see them talking about heat, you are heating something, radiation, infrared radiation. This is obviously unit 2, which is thermal energy. And if you look at the formulas I gave you, there's only one, okay? Delta E is equal to MC delta T. That's the one. So what is the M? I look for the mass somewhere in this whole thing. You see the shortcut. So, what is it? Let's work through it. We'll say M, what is the mass? The mass is 40 kgs. Times, what is C? We look for C here. 4,200 joules, and in brackets you say kg. It's joules per, in bracket it says kg degrees Celsius. Then it's going to be times delta T. What is our delta T? Delta T is 43 degrees Celsius minus 10 degrees Celsius. Then you're going to get your delta E. This is the energy, okay? What is the energy here? You're going to find delta E. What is that energy? Oh, hi, Navira. Okay. Hi, Navira. You text me, okay? If you want to text me on WhatsApp, it is +267 7138 3870. Okay? This is where you text me. Right. What is the answer going to be here? Say 40 times 4,200 times, you open bracket, you say 43 minus 10, which is 33, okay? So you can just say times 33. What do you get? 40 times 4,200 times 33, you get 5,544,000, okay? 5,544,000 joules. This is going to be energy, the energy transferred. Now, there's a whole lot of other stuff that talks about 60% and whatever. We'll talk about it. But I want to see, first, I want to see people use this. I'm not interested in the other parts. I want to see people use the formulas first. Can I see the formulas in action? You always start at the formulas. There's nowhere else. There is nowhere else. Please. There is nowhere else. This is where you start. You start at the formula, you get your answer here like this. That is how you start. The formula for chapter 3, you'll be like, oh, this is unit 2, thermal energy. Oh, this is unit 3, either use V's, F lambda, or the formulas for N or whatever. You can do any calculation in any paper. Let me give my answer in standard form. If I'm giving it in standard form, you always know that the comma is at the very end here, the very end. So you move 1, 2, 3, 4, 5, 6. We've moved the comma 6 times. You move it until you are left with only one number. So we've moved it 6 times. So it'll be 5.544 times 10 to the power of 6, because we've moved it 6 times. And this is joules, which becomes, of course, mega, if times 10 to the power 6 is mega, 5.544 mega joules, something like this. You can do it. You can even leave it in standard form, okay? Still fine. So this is now up to you. You can finish it off like that and stuff. Then we'll talk about the other parts. This is going to be enough. I'm going to give you questions. You have to do my questions. You have to send me my questions, and I'm going to go through them tonight. And tomorrow we continue, okay? Tomorrow is a Friday, but we have to push every single day. So don't be resting because tomorrow is a Friday. We don't rest because it's a Friday. We rest because we are done. Thank you so much, everybody.